Hey everybody, in this lesson video, I'm going to talk and just kind of provide some quick notes about chords and arcs within circles. So the first thing I want to do actually is draw a circle. So do your best to draw a circle. If you have a compass, that would probably be helpful. That is, wow, I thought it was going to be an eclipse. All right, or an ellipse, sorry. I was thinking of a moon. It's eclipse. Ellipse is kind of like that oval shape. So here's my circle, center C. And a chord is any line connecting 2 points on your circle. So let's make this chord here A, B. Again, this is a chord which chords connect any 2 points on the circle. And remember that this is circle C here because it's named by its center. All right, now from C, the center, to the edge of the circle, that is the radius. This is our radius here. And I'm going to call this radius CD. Now, we've talked about radiuses before, radii. Arcs are formed by parts of a circle. So an arc is really part of a circle. So I, in this circle, have now created this minor arc, AB. So I would call this minor arc AB. And to recognize it's an arc, we put that arc symbol over it. We could also name this BA. And it is minor because it is smaller than 180 degrees, or smaller than a semicircle. So we have minor arc, AB, and then that leaves us with major arc. Oops. And this one, since we have 3 points on it, I might as well call it major arc BDA. So that would be this, oops, this portion around our circle. So that is major arc, either major arc B, D, A, following the points around the circle, or A, D, B. And yes, I could call this major arc BA and be talking about, more than a semicircle, greater than a semicircle length. Just if you have 3 points, it's more helpful to name your arc by 3 points versus two if you have kind of two arcs you're looking at. So this is greater than a semicircle, bigger than 180 degrees, which is why it is a major arc. Now, if I have multiple radii within my shape, within my circle, so here's my radius CD, and I'm going to draw radius CF. That creates what is called the central angle. So now I have this central angle here. FCD, or angle DCF, with the center of the circle as the middle letter, as the vertex of the angle. And the central angle, in this case, angle FCD, it has the same measure as the arc formed between F and D. So this, what I would call minor arc FD, has the same measure as the angle, the central angle FCD. So I could say the measure of angle FCD, the central angle, is equal to the measure of arc FD. central angle FCD. I'm going to actually move this down. And I'm going to say is equal measure to minor arc FB, just for context. Okay. So something else I want to point out is what is an inscribed angle. We're going to draw a new diagram for this one. So inscribed angles, the vertex of the angle is on the circle itself. So if we draw a new circle here, this is going to be a little bit smaller. Let's still have the center be C. And now I'm going to have this inscribed angle. The vertex is going to be M. And then it really is made up of two chords, right? So here's chord LM and chord MN. So angle LMN is inscribed in circle C. And while there is an angle that is formed here, we also have this corresponding arc. And this arc is going to have the same measure as the central angle, right? As the angle formed from L to the radius, or from L to the center, I mean, forming the radius, and the center to N, right? So I could write this or draw this central angle here, LCN. And we know that that has the same measure as arc LN. So the measure of angle LCN is the same as the measure of that arc. So to represent the measure of that inscribed angle, the measure of angle LMN, the inscribed angle, is actually half of the central angle. So measure of angle LMN is half of the measure of angle LCN. Oops, sorry. Meaning this inscribed angle is half of the central angle, or this inscribed angle is half of that arc, right? Half of the measure of arc LN. All right, the last thing I want to point out in this quick lesson notes video is how to find arc length. And this is really a measure of distance in this case. And since an arc length, or an arc, I should say, is really like a fraction or part of a circle, I don't know why it decided to make that a circle there. Arc length is really just a fraction of the circumference of a circle. So this arc length, L, is equal to your measure of the arc in degrees divided by 360, and I'm going to write out what M is in just a second, times the circumference. So again, M here represents the arc measure in degrees. So you divide that by 360 to determine what's the fraction of the circle that is represented by this arc. And I'm going to multiply that times our circumference. So really another way of writing this is the arc length is that arc measure divided by 360 times 2 pi r, because that is the formula for circumference. And I have a 2 on the outside of this fraction, and in the fraction itself, I have divided by 360. So the 2 and the 360, that can simplify. And 2 over 360 is really like 1 over 180. So I could simplify this even a little bit more, and I could say the arc length is equal to that measure divided by 180 just times pi times the radius. So that is how we would find the arc length. Please let me know what questions you have. I want you to look through the OMHS learn and practice examples to work with this. Work on Delta, look at their examples and videos, and please email me when you get stuck.